Good morning. So morning, everybody. We are busy with the second lesson of electricity. And I think we already did number B. So we have to start with example C that I have here on the board. So there it is. So let's quickly look at C. Okay, so we're just going to do a lot of examples and then we will finish with electricity. Tomorrow we're going to do electrostatics. Okay, they say 3 resistors with a resistance of 3, 4, and 6 ohm and a bulb are connected in the circuit as shown below. Initially, all the switches S1, 2, and 3 are open, and the internal resistance of the battery and the resistance of the connecting wires may be ignored. And then they say, state Ohm's law in words. So you must be able to give Ohm's law. So you must be able to state Ohm's law. That is so important that you know that definition. So they say switch S is now closed. The voltmeter and ammeter reading are recorded. And then they say the voltmeter and ammeter readings when both switch S1 and switch S2 are closed are then recorded, as well as the reading when all the switches S1, 2, and 3 are closed. So, and then they give it to us on the table below. So they give us the reading if only switch S1 is closed, the voltmeter reading is 4.8. And if switch 1 is closed, the ammeter reading is 2.4. They say explain the increase in ammeter reading as more switches are closed. Okay. Now, what we need to remember is when we look at this picture, okay, if no switch is closed, there's no current flowing. If they close the first switch, so let's just look at the first one. So they just close S1. Then it means the total current are going to go through there. Only S1 is open. So what is the total resistance if only S1 is open? So the resistance is going to be that of the light bulb as well as the 3 ohm. But the moment when I switch S2 is closed, it means that I have 2 resistors now in parallel. And then the more resistors I put in parallel, the more I decrease the total resistance. And that's something that you need to remember for next year as well. So the more resistance in parallel, the total resistance will decrease. Okay. Now, if I add another one, then it means the resistance is going to be smaller than 3. So every time when I add a resistor in parallel, the total resistance increase. Therefore, the total current will increase. Now, the question was, explain the increase in the ammeter reading. So for 2 marks, they wanted you to say, the more resistors in parallel will decrease the total resistance. So you can say more resistors in parallel. Then you can say R total will decrease. And if R total decrease, then you can say I total will increase. And this is how we get the answer here for the ammeter reading at the end. So then they say calculate the resistance in the light bulb. So now when we go to this one, the light bulb, that resistance that we need to calculate. Okay. Now, say for instance, we just take it where switch 1 is closed. Only switch 1 is closed. You can decide which one you are going to take. I'm going to show you that you're going to get, in any case, the same answer. But say for instance, you decide that just switch 1 is closed. This will be the circuit diagram then when you look at that. Okay. Now they want us to work out the total resistance in the light bulb. So if only switch 1 is closed, the ammeter reading is 2.4. Okay. And the voltmeter reading is 4,8. Okay, now let's go back. Ammeter reading 2.4. Voltmeter reading is 4,8. it means that the total current that goes through this light bulb is 2.4 amps. And the voltmeter reading connected over the light bulb is 4.8. So what we're going to do now is we're going to say, right, for the reading, because I wanted us to work out the the resistance in R, in the globe. So we say R equals to V over I. So we use the 4,8 divide by the 2,4. 4,8 divided by 2,4 gives us an answer of 2 ohm. So that one counted, in any case it counted 3 marks. So look at the marks allocated and then you will know, okay, I can work out this one. All right. So the main thing is just R equals to V over I. The 4.8, that's the reading that they gave us, and the 2.4. Say, for instance, you use the information, oh my goodness, to the next page, where we have the ammeter reading and the voltmeter reading when switch S1 and S2 is closed. Then you have 6 and 3. So it means that we're going to substitute now for this one, 6 for the volts and 3 for the ammeters, and it's still going to give you 2 ohm. So any one of those readings that you got from the table would have been fine to work out the resistance in the globe, in this light bulb. It will still stay 2 ohm. Doesn't matter if all the switches is closed or just one switch is closed. Okay. The next one is where they say we have to work out the potential difference of the battery. So it means the total voltage. So they want us to work out the total voltage here. Okay, right. Now the main thing that you need to remember is that, say for instance, only switch S1 is closed, then the total resistance is going to be 5 ohm. The current is 2.4 for only switch S1 close. Okay, so let's do the options. So for instance, only switch S1 is closed. Then we're going to say the R total is then going to be the 3 ohm plus the 2 ohm, which is going to give us a total of 5 ohm. That's a total resistance. So the total current, R equals to V over I, is for only switch S1 closed. So let's quickly go to that diagram. So the ammeter reading is 2.4 for switch 1 close. Okay, so then we're going to use the amps as 2.4 here and the resistance as 5. So 2,4, let me just put that in, times 5 gives us an answer of 12 volts. Say, for instance, you choose to use that switch S1 and S2 is closed. Now, then when we work out the total resistance, we first have to work out the resistance in parallel, which is going to be R1 plus R2. And then we're going to say it's 1 over 3 plus 1 over 6. So when we work this out in parallel, we get an answer of 1 plus 2 plus 1, which is 3 over 6. So R parallel then is going to be 2 ohm. Okay. But then we must still say R total is going to be 2 plus 2, which is 4 ohm. So when we work out the total voltage, I'm going to use the 4, but the current is on the table for 2 switches closed, which is going to be 3. So then when we work this out, we're going to get an answer. There's 3. So then 4 times 3 is going to give me exactly the same answer as the previous one, which is 12 volts. And the same method I can use with all 3 switches is closed. So let's quickly do that one. So for instance, they closed all 3 switches, switch S1, S2, and S3. The first thing that we work out is the total resistance. So I start with the total resistance in parallel equals to 1 over R1 plus 1 over R2. And now I have a third switch that is closed. So it means a third resistance in this whole thing. Okay. Now when I go and look at the resistors, it's 3, 6, and 4. So I'm going to say 1 over 3 plus 1 over 6 plus 1 over 4. When I work this out, I'm going to get 4 plus 2 plus 3. So it is going to be 9 over 12, which is 12 over 9. So when we just work out R parallel equals to 12 over 9, which are supposed to give us an answer of 1,33, 1,33 ohms. That is in parallel. And then it means that you still have to work out R total. So we must still keep the light bulb in consideration. So we're going to say the total resistance in parallel is 1,33 plus the light bulb that we worked out that has a resistance of 2 ohm. So I'm going to add the 2, and then the total resistance is 3,33 ohm. Nah. And then we say R equals to V over I. Resistance is 3,33. What do we want to work out? The voltage and the current. I must go back to the table. So the table says if all three switches are closed, the current is 3,6. So let's go back to this one. So the current that I'm going to substitute in is 3,6. So therefore we're going to say 3,6 times the 3,333, and you will see the voltage is also going to be 12. So this is how we work out all the options. You just choose one option. But what I want you to look at is if only one switch is closed. Let's just check this. I just want to highlight this for you. If only one switch is closed, the total resistance is 5 ohm. If two switches is closed, the total resistance is 4 ohm. And then the last one, if they close all three switches, what's the total resistance? 1,33. So can you see, the more resistance I put in parallel, the lower the total resistance in the circuit. Okay, so that is how I can prove that when I add the resistor in parallel, it means the total resistance will decrease, therefore the total current will increase at the end. Okay, so this is just for you to see that it is true. I don't just say it, I proved it as well here with all the sums that we've done here. Okay. Now they say the next one is define the term power. Now, it is important that you know that power is the rate at which work is done, because sometimes they can just ask us to calculate the rate of which work is done in the 6 ohm resistor and not straightforward ask the word power. Okay, so power means the rate at which work is done, then you will get your 2 marks. Then 10.5, they say calculate the power dissipated in the 6 ohm resistor when only switch S1 and S2 are closed. So they want us to calculate the power in this one. Let's just get a new pen. Okay. They want us to calculate the power in the 6 ohm resistor. Okay. So it means it's going to be the power if switch S1 and S2 is closed. So they want us to work out the power in the 6 ohm resistor. Now, if we look at power, there's a few equations that we can use. Now, we can use power equals to V squared over R. So if we can go back, let's just go back to the information sheet that I put in here. So we can use this one, V squared over R. Any one of these will be fine to work out power. V times I or I squared times R. It depends on what we have. Now we have the R because I said it's in the 6 ohm resistor. So I must use one that at least have R. And then if I can work out the current through that 6 ohm resistance or the voltage over the 6 ohm resistance, then I can work, I can get the power. Now let's go back to the sum. All right. Now when we look at this sketch that you see here, wait, there it is. I know I'm going to use, let's say we're going to use the one because now we know the voltage over the globe. So the voltage over the globe is the voltage in series, and that would be 6. I think we worked that out. Let's just see in the previous sums. So that's where we work out the total for each. Okay, I think I have it. That's a 4.8. They say if only switch S1. Okay, look at the table. Okay, if S1 and S2 is close, what's the voltage? It is 6. So I'm going to use that. Okay, and the ammeter reading is 3. So we can use any one of those two. So the 6, the ammeter reading is 3. But this is the total current. Okay, so everywhere where you see the blue, the ammeter reading is 3. But through the 6 ohm resistor, the current divided into 2 parts. So the current that goes through the 6 ohm resistor is not 3. Okay. Then when we work out the total voltage, we prove it with all the types of sums that the total voltage, the EMF, is 12. So I can, if I have a voltmeter reading there, this voltmeter reading will be 12 volts. And now I know that the volts in parallel plus the volts in series will give us the total voltmeter reading over the battery. So it means that V total equals to the volts in parallel plus the volts in series. So if we substitute in, the total voltage is 12, and then the volts in parallel I need to know, but the volts in series is 6. So the volts in parallel is going to give us a total of 6 volts. And then you must remember, as I taught you yesterday, if the voltage over all three the resistance is 6 volts, it means the voltage over the 4 ohm resistor is 6 volts, the voltage over the 6 ohm resistor is 6 volts, and the voltage over the 3 ohm resistor is going to be 6 volts. So I have the voltage and I have the resistance, then I can work out the power. So the equation that I'm going to use, okay, is going to be power. I have the voltage and I have the resistance. I think the easier one to use is V squared over R. Okay, the voltage is 6 to the power of 2 divided by 6. And 6 to the power of 2 divided by 6 gives us a total power of 6 watt. That would be your final answer. If you decided you want to go with the other equation where we use current, then you had to work out the current through the 6 ohm resistor and not the total current. Okay, so I think it's easier to use the voltage. Volts in parallel is everywhere the same, and voltage in parallel plus the volts in series will give us at the end the total voltage that is in the circuit. So what did I do? I said the total voltage in the circuit is the volts in parallel plus in series. So I know the voltmeter reading if the two switches are closed is 6 volts. And then I can say 12 minus 6. I get the voltmeter over parallel. And then I use only the 6 ohm resistor because I want the power in the 6 ohm resistor, which is at the end then 6 watts. Okay. Next question that they ask us is to say 10.6. How will the brightness of the bulb be affected as more switches in the circuit are closed? Now, can you remember the brightness and the current goes together. So if the current increases, can you see the current increase here? As more switches are added, the current increase, then the brightness of the light bulb will also increase. So in 10.6, you're going to say increase. And then 10.7, they want you to explain the answer. Okay. Now, if the switches are closed, okay, what's the first thing that's going to happen? If the switch closes, the total resistance will decrease. That's the first thing that you say. Total resistance will decrease the more switches that are closed, because the more resistance I put in parallel, the total resistance will decrease. Then we say, but what we need to remember is that the total current, I total, will increase. And if the total current increase, it is important to remember that power is directly proportional to I square. So it means that the power will increase. And if the power increase, the light bulb will be brighter. So therefore, the increase in power, increase brightness. Brightness will increase. Okay, so that's your explanation. It counts 2 marks, but you write everything down that you can. All right. Okay, so that was question number C. Let's look at question number D. They say, consider the following circuit diagram below, and they give us the internal, they say the internal resistance of the battery and the resistance of the wires can be ignored. In 12.1, they say, calculate the value of resistor R if the total resistance in the circuit is 4.8. Okay, so now we only have resistance in terms of R, but it is important that you go and check which resistors are in parallel with each other and which resistance are in series. So when I look at this one, I'm going to say total current in series, that's it. So everything else is in parallel. Then it divides into 2 places. So the one is there, so I only have the 4R over and then this part. So if I can rearrange this, I would say I have a battery, okay, and then I have a 4R there, and in the other one I have a R, a 2R, and a 3R. So this is how it looks like. These are in series with each other. So R, 2R, and 3R is in series with each other, but in parallel with the 4R resistance. Now they say we have to calculate the value for R if the total resistance is 1.4. So we work in 4.8. So we work in terms of R. So we're going to do the following. Going to say 1 over R parallel equals to 1 over, and the one at the top is 4R plus 1 over, and now I add all the R's for the one at the bottom. So it's R plus 2R plus 3R. It's going to give us 6R. So this is what we're going to do. And now we just have to solve R, but we have, they say the total resistance in the circuit is 4.8. So I'm going to substitute in 1 over 4.8 equals to 1 over 4R plus 1 over 6R. So now I'm going to work this out with my calculator, and then you will see that you're going to get an answer, because we get a LCM for this, so we can actually say it's 4.8 equals to It's going to be 12R at the bottom. 4 times 3 is 12 and 6 times 2. So it's 5 over 12R. So I can say 4, 8 equals to 12R over 5. So when I solve this, it's 4, 8 times 5 divided by 12 equals to R. Okay, now let's just work it out with our calculators. So we say 4.8 times 5 divided by 12. And then you get an answer of 2. Answer is supposed to be 2. So your R, 1R is 2 ohms. Okay, so this is the maths that you're going to do. So it's 1 over R parallel equals to 1 over 4R plus 1 over 6R. Then I get the total over 12R because 4 goes in 12 and 3 times and 6 goes in 12 and 2 times. And then I manipulate the formula and get an answer for R at the end. Okay, remember that's just 1R. So actually when we look at this one is going to be 2 ohm, but this one is 4 ohm, that one is 6, and that one is 8 ohm. So that's a total resistance. Now they say, calculate the reading on the voltmeter if the current through the 4R resistor is 1.8. So now they give us this green current. They say if there were ammeter reading there, the reading would have been 1,8 amps. And they want us to calculate the reading on the voltmeter. So they want us to work out the reading only over that one. So with the information that they give us, just I can work out the voltmeter reading over this one. So I can work out the voltmeter reading over this whole thing, okay, which is the total voltage in the circuit. So that's what I'm going to start with. So I'm going to start with the R equals to V over I. Resistance is 4R. So if I take the 4R and then I know R is 2, so it's going to be 4 times 2, so which is going to be 8. So the resistance there is 8. I want the voltmeter reading the current as 1,8. Then I say 1,8 times 8, and I get a voltmeters of 14,4 volts. Okay, so this would be the voltmeter reading. This one is 14,4 volts, as you can see it there, over the 4R. Okay, so it means that the total voltage over all three of this resistance is 14,4. Okay, so the only thing that I need to know now is the current, because if I have the blue current here, I know what's the ammeter reading there. It's the same everywhere where you see the blue. Then I can use the ammeter reading and the resistance to work out the voltage only over 2R. Okay, so my main function now is to work out the current in the blue line, as you can see it there. So I'm going to use R equals to V over I. Okay. The voltage I have, because the voltage is the 14.4. So I'm going to substitute in 14,4. I want the current. The resistance, now let's go back. Can you see the resistance is R plus 2R plus 3R, which is going to give us a total of 6R. But 1R is 2, so 6 times 2 is 12. So for this, I'm going to put in 12. So the current is going to be 14,4 divided by 12. Now, if I take that 14,4 divided by 12, I get a current of 1,2 amps. So that's the current in that line. And now let's go back to the picture. If I have this 1,2 amps, I have the current, I have the resistance. Now I can work out the voltmeter reading. So I can say R equals to V over I. I have the current, it's 1,2. I want the voltmeter reading, and then the resistance is only 2R. So 2 times 2 is 4. So we're going to say 4 times 1,2 gives us an answer of, so for this voltmeter reading, our answer is going to be 4,8 volts. So that is the voltmeter reading at the end for question 12.2. Okay, question 12.3, let's just go back. 12.3, they say calculate the energy converted in a resistance 4R in 2 minutes. Now, the moment when you have to calculate the energy, we need to remember that we're going to work out the W, the work done, measured in joules. Okay, now let's just check where we are now with the circuit diagram. Okay. Right, the question says we have to calculate the energy in the 4R in 2 minutes. So they want us to calculate the energy here in 4R. Okay, what do we have for the 4R? We have the current, because we worked that out in, I think, the first question or so. So I have the current, which is in that part of the, through the 4R, is going to be, the current was 1.8. Okay, I have the current, and then I have the voltage, because we worked out the total voltage over the 4R. And if I can remember that correctly, it was 14,4. So I have the current, I have the voltage, and I have the resistance, because it's 4.2, so it's 8 ohm resistor. Okay, and now what do I want? I want the work done in 2 minutes. Remember, I'm not allowed to use minutes. I have to change it to seconds. So the moment when I do the sum, I can actually choose. There's so many equations that I can choose. Now let's say I choose the current, the resistance, and the time. So I can say the work done equals to I squared R delta T. Okay, so the current is through the 8 ohm resistor is 1,8. Okay, remember that must be to the power of 2. The resistance is 4 times 2, which is 8. And the time that we're going to use, they say it's 2 minutes, and minutes, 2 seconds is times 60. So it's 2 times 60. And then when we work this out, we're going to get an answer of 1036,8 joules. That would be the answer. Okay, so it's 1,8 to the power of 2 times 8 times 2 times 60, because we have to use seconds and not minutes, and then you get your answer, which is 1036,8 joules, as you can see it there. Okay. Right. The next question that they ask us is at 12.4. So at 12.4, they say the 4R resistor is replaced with an ammeter. Okay. How will the reading on the voltmeter be influenced? Write down increase, decrease, or remain the same. Okay. So now, if we go back to this one, the 4R is replaced with an ammeter. We just use this. So there's no resistance. So actually what we did is we took out the resistance in parallel. Okay. So the total, and they want us to know what is going to happen with the total voltage. So we know that when we work this out, if the current is going to increase, if the current has it's going to increase, it means that the voltage is going to change as well. but the current and the resistance is inverted proportional. Now, if we look at this one, if they change this with the ammeter, which has less resistance, let me just get a pen there. Okay, there's the ammeter. So this is now an ammeter, and it has much less resistance than the 4R. Okay, so it has a low resistance ammeter, and then all the current is going to go through this part because that's the easier way to go. Okay, so all the current, this is what's going to happen. It's going to go in this direction. So what's going to happen to the voltmeter? If the resistance is going to actually, all the current is going to go there, then we can say the voltmeter will decrease. So the answer that we're going to give here is decrease. And then they say, explain the answer. Now we can say the ammeter has a lower resistance. So I'm just going to draw it like that. Ammeter has a lower or resistance, and because it has a lower resistance, all the current goes through the ammeter. All current goes through the ammeter. Okay, so this is the one explanation. Another explanation, we can say that the ammeter short circuit the resistors. So it's going to take out the total resistance. No current flows through 2R. Okay. Or we can say the ammeter, there's no, yeah, that's it. No current flows through the 2R resistor, or the ammeter shortcut the system. But that's actually what's happening. Why? Because current follows the easier route. So if I don't put in any resistance here, all the current is going to go through there, and it shortcuts this. So no current is going to go through that, the 2R for the voltmeter to change. Okay, so this is what we're going to give. Actually, the voltmeter reading is going to decrease, and we'll have a reading at the end of 0. Okay. Right. The next one that we can look at, what I have here, is number E. Okay, now let's look at number E. They say the following. All right. In the circuit below, the internal resistance of the 6 ohm battery is neglectable. Okay. The resistance of the connecting wires is also neglectable. And when the switch S is closed, the current in the 6 ohm resistor is 0.6 amps. So that's the first thing that I'm going to put in here. So that current, if I have an ammeter reading there, this ammeter is 0.6 amps. That's the first thing that I put in. Again, can you see in almost every paper they ask you to state Ohm's law? So to give Ohm's law in words. All right. Then the next one they say, calculate the current passing through the 4 ohm resistor and count 4 marks. So they want us, we have the current passing through the 6 ohm resistor, but we don't know the current passing through the 4 ohm resistor, which is going to be equal to the total current at the end. Okay. Now, when we look at this one, we have to remember that when we work out this voltmeter reading, it is connected over the 6 ohm resistor and the 0.6 amps. It actually is, and that's what I need to remember, will have the same reading as a voltmeter connecting over the 4 ohm resistor. Can you see that? Okay. So if I can get V1, I have the voltage over the 4 ohm resistor. And if I have the voltage and the resistance in this part, it means that I can work out the current going through the 4 ohm resistor. So we start with the red part. I'm going to start with R equals to V over I. Resistance is the 6 ohm. I want the voltage, the current is 0.6. So 6 times 0,6 gives us a total of, for the voltage, of 3,6 volts. Okay, so that would be 3,6 volts. So immediately in green, I can say, right, this one is 3,6 and this one is also 3,6. Okay, and now I can work out the green current because I can say R equals to V over I. Resistance in the green part is 4. Voltmeter is the same. And then I want to work out the current. So the current is going to be equal to 3.6 divided by 4, which gives us a total of 0,9 amps. Okay. So that means if I had an ammeter reading there in the green part, it would have been 0.9 amps, which must be a bit more than in the 6 ohm, because the larger the resistance, the smaller the current. Okay. The next one is 11.3, the total current in the circuit. Okay. Now when we look at this, the total current in the circuit, let's just underline or show where is the total current. Everywhere where you see the blue part, that will be the total current going through that. Now remember, no current is going through a voltmeter because a voltmeter has a high of a resistance. So if I want to work out the total current, it means it's the green one plus the red one. So I total is actually just going to give us an answer of 0.6 plus 0.9. The way that we're going to write it is we're going to say I total equals to 0.9 plus 0,6, and then the answer is then, of course, 1.5 amps. Okay, that would be the total ammeter reading. You know that you're going to add the current through the 6 ohm resistor and the current through the 4 ohm resistor to get the total current at the end. Okay. The next question is 11.4. So let's look at 11.4, the resistor X. So they want us to determine this resistor. Okay, right, that R. Now the first thing that I need to remember is that the total voltage here at the top, the 6 volts, is the total maximum voltage. So it means the voltage over parallel plus the voltage over series will give me the total voltage there. So when I start this sum, I'm going to start it by writing it as follows. I'm going to say V total equals to the voltage in parallel plus the voltage in series. Total voltage, as you can see, there is 6. So I'm going to give a 6 there. Voltage in parallel is then 3,6 because we worked it out. So I'm going to say the voltage in parallel is 3,6. I want to know what is the volts in series. So 6 minus 3,6 is going to give us the volts in series. So the volts in series is going to give us a total of 2.4 volts, 2,4 volts. That's the voltage that we're going to have over that resistor. So that R. But they want us to determine the total resistance in R. So now we have this reading. We know what is the total current, because we worked it out in the previous one. It was the 0.9 plus the 0.6. So the 0.9 plus the 0.6, if you look at that, we got an answer of 1.5 there. So if I have an ammeter reading here, it will be 1,5 amps. Okay, so I have the voltage, I have the current, I can work out the resistance. So I can say R equals to V over I. Okay, the voltage is 2,4. The current is the total current in the circuit, which was, what was it? 1,5 total current in the circuit. And now I have the total resistance, which is 1.6 ohm. That's a total resistance that we have in R. Okay, so if you look at that, then we have the total resistance in R. Okay. The next question that they're talking about is the 4 ohm resistor gets hotter than the 6 ohm resistor after a while. Explain this observation. Okay. Now, here we must keep in mind that the higher the power through a certain resistor or through a certain wire, the warmer it will get. Now, if we go to this one, we must remember that we have the 4 ohm and the 6 ohm resistor. And according to us, the most current is going to go through the 4 ohm resistor, and the least amount of current is going to go through the 6 ohm resistor. Okay, so when we look at that, we can actually say that the power in the 4 ohm resistor is going to be greater, therefore it will be hotter. But when we talk about heat in a question, we talk about energy. Heat is energy. Okay, so in this case, the moment when it heats up, we can say that the energy is going to increase. So energy, and what is the relationship between energy and the current? Okay, now if I look at this equation, I can say I square R delta T. Okay, now what happened for the same time interval, so the time stays the same, I squared R delta T will be greater for the 4 ohm resistor than for the 6 ohm resistor. So this I square R is going to be greater for the 4 ohm resistor. Okay, because more current is going to go through the 4 ohm resistor. Now let's just see if it's going to be true. Because if we go back, you will see that the current through the 4 ohm resistor was 0.9. Okay, now let's quickly look at that. Oh, where it's now. Okay, so it is 0.9 to the power of 2 times 4. Okay, now let's just work this one out and see what the answer is going to be. 0.9 to the power of 2 times 4. Answer is going to be 3,24 because the time for both is the same. For the other one, for the same time, what was the current? Current was 0,6 and the resistance was 6. Now let's see if it works. So I'm going to use 0,6 and then the resistance was 6. So 0.6 to the power of 2 times 6. Answer is 2,16 joules. So can you see which one is the greater one? This one, the one that has the greater current, the smaller resistance. And this is why we can say that that would be the explanation. Let me just write this down. I square R delta T. And then we can say, okay, for this one, it is the resistance, the 4 ohm resistor. So let's just do this. And we say this is for the 4 ohm resistor. And this one is for the 6 ohm resistor. Okay. And then when we look at that, we have to indicate that the time remains the same. So the time is not going to change for any one of the two. The time is going to be the same. So that's why I don't use it. But then I substitute in the current and the resistance for both. So the moment when resistor, the 4 ohm resistance gets hotter than the 6 ohm resistor after a while is because the current through the 4 ohm resistor is much greater than the current through the 6 ohm resistor. Okay. The next thing that I want to explain to you is I knew that we're going to have a few minutes left. So I want to draw a circuit diagram on the board and then do the diagram with you. So I have this battery. Okay, let's say it has 3 cells in it. It goes like this. There I have an ammeter. I want you to draw this with me. Then I have R1, so that's resistance 1. Over the resistor 1, I have a voltmeter, V1. Okay, then it goes on. Current divide, ammeter there. Let's call this ammeter A2. Okay, let me just do it nice and neat. Okay, A2. Okay, then I have a R2 here, R2. And over the R2, I have a voltmeter, V2. And then at the bottom, I have a R3. I have A3. And then there it goes, and then it goes up, and then to the battery that we have there. And then another thing is, this is going to be V voltage 4. So that's the voltmeter reading that we have there. Okay. Now the information that they give us is they say the total voltage over the battery is 1.5. So they give us this 1.5 volts. The next thing that they say is that R1, this is this resistance, is 3 ohm. So let's put that one in. They say R2 is 2 ohms and R3 is 1 ohm. And now they want us to solve the rest of that. So they want us to solve the ammeter readings, the total resistance, the voltmeter readings, the everything that is left. Okay, so this is actually A1. Okay, now because I only have resistance, I'm going to start by working out the total resistance in the circuit. Now, this is parallel. So this one goes parallel, and this is where the current is going to divide into 2 parts. So I'm going to start to work out the total resistance in R parallel. So I'm going to say R parallel equals to R2 plus 1 over R3. So it's going to be 1 over 2 plus 1 over 1. Okay. So when I add this 2, I'm going to get an answer of 2, 1 plus 2, which is 3 over 2, so it's 2 over 3. So for R parallel, it's going to be 2 over 3. So when we work that out, we get an answer of 2 divided by 3. Answer is going to be 0.667. Let's leave it like that. Okay. But if I want to work out R total, I'm going to say R total equals to R in parallel plus the R in series. So it's 0.667 plus, and the R in series is the 3 ohm. Did I work it out wrong?
Ma'am,
Yes. It's
for
1.5.
for the second fraction on your
Yes.
working, why it
Yeah.
says 1 plus 2 over 1 plus 2 over 2.
Yeah.
It's not 2 over 3, but it's 3 over 2.
It's what? 2 over
3
2.
over
3 over 2. Yeah, it is 3 over 2. But then when you swap it around and you just get R parallel, remember this is still 1 over R parallel. Okay, so it's 3 over 2. And then if I just want R parallel, I have to swap it around. So then it's 2 over 3. Are you all right with that?
Yes, ma'am.
Okay. So then you get the parallel resistance, which is 0.667 plus the 3. And then the total resistance is going to be 3.667 ohm. Okay. Are you, is it fine with you? Are you agreeing? Okay. So the total resistance in this circuit is going to be 3, what is it? 3.667 0.67. Right, now let's go to the total current. Okay, so now I can work out the total current, which is A1, because that's in a series circuit. So now I can say, right, for the total current, R equals to V over I. So I used the total resistance, which is this 3,667. I use the total voltage, which is 15, and then I want the current. So the current is going to be equal to 15 divided by 3.667. Answer that we get is 4,09 amps. That's the ammeter reading for the total. So 4,09. So let's fill it in there, amps. Okay. Right, now we can work out V1 because now we have the current that goes through that one. So to work out V1, I'm going to say R equals to V over I. Resistance is 3. I want the voltage. The current is 4,09. So the voltage that I'm going to get for V1 is the 4,09 times the 3, which is then 12,27 volts. So this one is 12,27 volts. Then I can say, right, I know that the volts in parallel plus the volts in series will give me the total voltage. And I know that V2 and V4 has exactly the same reading. So then I can say V total equals to V in parallel plus the voltage in series. Total is 15. I want the parallel. In series, the voltage is 12,27. So the voltage in parallel is going to be 15 minus the 12,27, which gives us 2,73 volts. So V2 and V4 is both 2,73 volts. Okay. And now they can ask you to work out A2 and A3, where we just use R equals to V over I. So for A2, I'm going to say R equals to V over I. That's for A2. Resistance for A2 is 2 ohm and the voltage is 2,73. So the resistance is 2, voltage is 2,73. Then I want the current. So the current is going to be 2,73 divided by 2. Answer is 1,36 amps. And then the next one, and also the last one that we have to solve is A3. So if we work out A3, we are going to use R equals to V over I. Okay, voltage is the same, 2,73. Want to know what's the current? The resistance is 1 ohm, okay, for R3. So 1. So it means the current is going to be 2,73 amps. Okay, so that is the electricity sums that I'm doing with you today. Tomorrow we will start with electrostatics, which is also a very important theme for next year as well. You must take care. See you tomorrow. Goodbye.